Hi, welcome to the TechHub.training solution video for the Normalization Station challenge in Alteryx. Prior to watching this video, we encourage you to try and find your own solution so that your learning experience is not hindered. But if you've been trying and are struggling, or if you have found your own solution and you want to compare it to mine, then hopefully this video will be of use to you. After you do find a solution, we encourage you to reply to the challenge page with an image of it or a description of how you did so that you can be a part of the community that we have here. So let's go right into the challenge. Keep in mind that it is likely that your solution that you have is different from mine, and that's okay. That's usually how data analytics work. There are many ways to approach the problem and to reach a solution, but what's important is getting to that solution in the end, ideally as efficiently as possible. So you might see some differences between mine and yours, and that's okay. So thinking about the instructions that you receive in the Word document, you are given a flat file that has a lot of different information and about different authors for accounting journals and other similar ones, and where those authors are from, where they graduated, what year, and whatnot. And you are told that each of these boxes represent a table that you're going to create. Now, you might feel rushed to create these tables right away, but if you want to make these tables effectively and do normalization correctly, you have to understand the data that you're working with first, and then you can create the tables, because it's a step-by-step process and you can't do this efficiently or effectively if you do not understand the data that you are working with. And that's true for almost any data analytics process. You have to understand what your goal is and what you're using to reach that goal. And so if you load in that Excel file that you're given into a input data tool and run the workflow, you will be able to see all of this data, and you should spend, a couple of minutes, around 5 to 10, understanding the data that you have. So again, author date, PhD, and work university names, year PhD, article title, journal title, year published, topic area, and methodology. The point of normalization is for building relationships between different items that exist in your file so that later on you can use them to reference each other, and things that are unique are defined as unique in those databases. Normalization really helps databases run effectively and efficiently, and it makes sure that there's no data errors, which is probably the most important part. So there's no superfluous data, there's nothing extra, there's nothing that is missing between the things, and they all connect together. And so that's the point of normalization. So if you can visualize that, then it makes the process a lot easier. That's step one. And the second step is understanding, when looking at these tables, names that you're given, what you need to include for them to be considered normalized. And so generally the way I go about normalization is I think about, one, the tables that I have, and two, if I don't have the tables, what things I can create that are associated with only one thing and one thing only. And then you can merge that all into a singular data file, which is the goal at the end of this challenge. And so you see, and you'll see it as we go along, but journal that the article is published in is not tied to anything specifically except the journal itself. Now, the article might include the journal, but it also might not. And there's actually a article journal table, and they reference each other. And so Keeping these things in mind will help you create the tables as we go on. I'm going to stop talking so much about how you do them and actually what I did, because a lot of it can only come through practice, and it's easier to visualize yourself as I'm showing the solution than it is me explaining it. So these two tools are in there immediately so that the data is changed to the correct types so you can actually work with it. Because, for example, year is not always going to be friendly and it might not concatenate well. In any case, we want to make sure that these year columns are integers instead of strings. So let's start first with university, because that is the most complicated one. And each of these you can see are pretty similar, and that is true for almost the entire flow. So starting with university, you may have noticed when I was explaining the data that there's both a PhD university and a work university. So what we can do is separate both of those out with different select tools, selecting work university for one and PhD university for the other, and then using a union tool. The union tool is effective because it removes all duplicate items that exist between these two. Like, let's say there's someone who has a PhD and works at the same university as where they got their PhD from. In the union, even though these two data sets are different, ultimately they will be merged into one and those duplicates will be removed. So you'll only get one record, even though there might be two coming from the left. So after that union, we want to find the uniques that appear, and then the important part of normalization. So we see that there's 658 universities. The important part of normalization is you want, when you have these normalized tables, these are all technically third normal form, just these three alone, because they have just the key and the ID that each value is assigned to. So you're going to, when you do this record, you're going to get an ID for each unique university that exists. And so that's 658 records. And I'll explain. These summarized tools are just so that at the end, or if you're viewing my solution without this video, you can see how many values you should have in each table that you create at the end. So next, journal, topic, and method all follow the same pattern. University is just a bit different because it has this union, but journal, you want to just select the journal, and notice again there's nothing else that really is related explicitly to the journal, so you only want the journal title, and then you're going to get a unique value on that and then assign a record ID to each of them. And the same is true for topic. There's only a topic area, assign each of those, each unique value of those an ID, and then method, the same thing. Select only methodology, unique values, assign them each a record ID. So then you're going to want to append each of those to your original data set, because later on, when we get to article and author, you're going to use not the names of the university that they're from or the methodology and topic that the article uses. Instead, you are going to reference the IDs that we created, and that's why we had to create these four first. Each of these only has a single thing that is attributed to that specific table, and that's why it's third normal form: methodology, topic, journal, title, university, ID. And so we're going to put those back into the original data set using joins. And you can join them back, each one on the name for the section that you're on. So methodology here, and I would recommend getting rid of the duplicate data. So if you're putting in the right method, this says what input it's coming from. So from the right input, which is connected to our method. You're going to remove it so that it doesn't clutter up your data. And then you're going to do the same thing for topic using topic area, journal using journal title, and then you're going to do 2 joins for university because similar to that union where we have PhD and work universities, we want to make sure that each author has their PhD university included and their work university included. And so you're going to do the first one on PhD university name from the original data set to the university name that we created in the university records with their ID. And you should make sure that when you do this, that with these select tools, I like naming them or for university at least, to be something descriptive instead that's similar between them instead of something different, because you only want universities to show up once. So you're going to do a join for PhD on the left to the right university name, because right is down here, university, and then again, work university name to the right university. And remember each time to get rid of the extra info that comes from the right table that you don't need. You just want this methodology ID, or the ID from the right table to be carrying over. So your data at this point will look like this. We haven't moved on to author and stuff, but we have PhD University ID 1, Work University ID 1, and we see, I kind of explained that earlier, if they work at the same place, you only want the one ID, and the duplicates are removed. Journal ID is there, topic, and method. Okay, moving on. For article and author. Let's look at author first, since it includes the universities. The author table, of course, has the author name, and the other thing that's unique to them is year PhD. That's never going to change. That's not associated with any other table. But then you're also going to include PhD of their university ID for their PhD and their university ID for their work. And this is why it's important that we did those first 4 tables earlier before moving on, and putting them in the original data set before moving on here, because otherwise we would have to put in the names, and so we would have names written out multiple times, when instead we can have one item that's linked back to just a single university. And so you can see kind of here how this really reduces the amount of data that we need to use to run our records, and it makes it a lot cleaner because you can just reference immediately that ID of the university. And then similar to before, we're going to get a unique value on all of them, and then we're going to assign a record to each, a record number. So author has that column, and each of these values are going to be unique to each author. It will result in 2.7 thousand. Article. The article has to be published in a journal, so it can't be standalone, and so article is going to reference that journal ID that we created earlier, and then year published is only going to be exclusive to that article. And so this is second normal form, where it has the key, of course, that are related to it, but then also references a foreign key in journal ID. And so same thing as always. From prior, we're going to do a unique value on everything, and then assign a record ID to each of those articles. After that, we're going to do the same thing, join in these records that we just put in to the original data set, and then match them and remove the things that are extra that we don't need. We just want that article ID for this one, and then the next one, we just want the author ID. So now your data set is actually complete. We do need to make 3 more tables, but you can output this, and it's in the instructions for you to output this to a CSV. Now that you do have your full flat file updated with these IDs, you could even get rid of author name, university name, article title, journal title, year published, topic area, methodology, because every other column besides the IDs is not even technically needed. You can reference everything, but this is our flat file. It's completed. It's full of the IDs. The last section is for the last three tables are concatenated key tables. And if you're looking at a relationship diagram, then it's a lot easier to explain. So let me open up a diagram of what this looks like. So I created this in Access so that it is very easy to visualize. And you can see this in the hints and suggestions section of the document. But these are the different tables, and the last three that we're creating are these concatenated key tables. Concatenated key means neither of the items that are like every other table has a primary key. That's what we created with the IDs in each of those sections. So method, topic, journal, and university, those all have IDs on them, and they're third normal form, and they're easy to reference because these are never going to change. And you might add more, and that'll add more keys, and then you're going in your other tables going to reference those. So these are foreign keys in author, the PhD and work university IDs, and they reference this university ID. Article, foreign keys, journal ID, but its primary key is still article. And so these concatenated keys exist because they are many-to-many relationships, and in normalization and data analysis, we call that the deadly embrace. And so you want to avoid doing that because it is very hard to manage having many-to-many relationships without cluttering your data. And so we create an extra table with those relationships, and these are concatenated primary keys. It means both of them together exist and hold essentially the data item. And it solves the problem of many-to-many because now both of the tables that they pull from, for example, let's look at article and method, are now one-to-many. And so that solves the problem that we could have with multiple items referencing each other in both tables, and it makes it a lot less cluttered. And so article method, we're going to select just the IDs that we created and input in the flat file for article and method, and then we're going to find the uniques for that, and that's important because there's 1,664 unique records, but there are 3,666 duplicates of those. So the article and the method can be published in separate places or just referenced multiple times, or maybe it has different authors. And so we want to reduce that redundancy. And then the same thing, article topic, article ID, topic ID, and these titles are very descriptive and helpful in that way. And then author title, or author article. So that has the article ID and the author ID. So now, again, looking at the sums, I just did a union of everything, summarized it, and then did a transpose. And these are the values that you should have that are unique to each table. Okay, hopefully this video was helpful to you. Hopefully you learned some principles of data normalization, and you are also well on your way to maybe doing database management, or at least understanding the way databases are structured so that you avoid data errors and redundancy. And hopefully that challenge helped you get there.